I know you guys were super bummed when you thought we were finished talking about logarithms. Fortunately, we are not. We are going to continue talking about them, and today we're going to talk about solving equations by using logarithms. And we're also going to talk about solving logarithm equations. The learning targets for this lesson: we're going to solve exponential equations with exponentials on one or both sides. And we're going to solve logarithmic equations with logarithms on one or both sides. We're going to start by talking about exponential equations with an exponential on just one side, which means if I have some base raised to an exponent on just one side. That's what I mean by exponential. So actually we should write that. Exponential is some base Okay, so the steps. The first thing that you're going to do is you're going to take the common log of both sides. So take the common log, because it's in your calculator, and we're going to have to use our calculators for this. Common log of each side. The common log is log base 10. That's the one that's in your calculator, and we don't need to write the base 10. We just write log. So this is the equation that I'm starting with. I'm going to take the log of both sides. So I'm going to take the log of the left-hand side and set that equal to the log of the right-hand side. So I have inside the left-hand log, I'm going to have 5 to the 2x power, and inside the right-hand log, I'm going to have 16. So I took the log of both sides. The next thing I'm going to do is I'm going to rewrite the logarithms so the variable is not in the exponent. So right now this variable is in the exponent. I want to take it out of the exponent. So I'm going to rewrite the logarithms so the variable is not in the exponent. Okay, and I know from the last lesson, my rule is that if I have an exponent inside of the logarithm, I can move that exponent to be a coefficient instead. So I'm going to move that exponent to be a coefficient instead. So I have 2x times log of 5 is equal to log of 16. The next thing I'm going to do is I'm going to divide each side to isolate the variable. So I'm going to divide everything on the left-hand side besides x to get rid of everything except for the variable, isolate that x. So I'm going to divide each side to isolate the variable. I want to get that x by itself. So I'm going to take what I started with. I started with 2x log of 5 is equal to log of 16. And I'm going to divide both sides by 2 log of 5. So everything that's not the x. So I want to take, so this is my x. This is what I want to get by itself. I'm dividing by the 2 and by the log of 5. And I'm going to do that. What I do on one side, I have to do on the other. So divide by 2 log of 5. And then I'm going to solve what this is. So I'm going to have x on the left-hand side is equal to, I have log of 16 divided by 2 log of 5. And then I'm going to put that in my calculator. And when I put that in my calculator, I'm going to end up with, I'm going to end up with x is equal to 0.861 if I round to the nearest thousandths place. So this is my answer. The last step, the last thing I wanted to do was I wanted to solve for x, or use a calculator is what I'm going to say. I want to use a calculator. So if you don't have a calculator, you're going to need one. You absolutely need one for this unit. All right, so those are the steps. And all 3 of these problems, 1, 2, 3, have an exponential on one side. So I have a base raised to an exponent on one side of the equation. The other side is a constant number. For the first one here, I'm going to take the log of both sides. So I'm going to do log of 3 to the x power is equal to log of 4. So I'm going to do log of 3 to the x power is equal to log of 4. From there, I'm going to rewrite the logarithm so the variable is not in the exponent anymore. So I'm going to write x to the left, and I'm going to have x times log of 3 is equal to log of 4. From here, I'm going to get rid of everything on the left-hand side, divide by everything on the left-hand side that's not x, to get that x by itself. So I just have log of 3. I'm going to divide by log of 3 on the left, and I'm also going to do that on the right. What I do on the left, I have to do on the right. I'm going to end up with x is equal to, I'll have log of 4 divided by log of 3. And when I do that in my calculator, I have to use my calculator for this. I'm going to do log of 4 divided by log of 3. And I'm going to get about x is equal to 1.262 if I round to the nearest thousandths place. And that's my answer. For the next one, I'm going to do the same thing. I'm going to start by taking the log of both sides. So I take the log of the left, take the log of the right. So in the left logarithm, I'm going to have 6 to the 2x power. In the right logarithm, I'm going to have 21. I just took the log of both sides. From there, I'm going to take this exponent that has a variable. I'm going to move it to be a coefficient instead. So I have 2x times log of 6 on the left-hand side is equal to log of 21 on the right-hand side. And then I'm going to get rid of everything except for the x on the left-hand side. So I'm going to divide by 2, this 2 that I see here, and also the log 6. I'm going to do that at the same time. Divide by 2 log of 6. If I do that on the left, I do that on the right. 2 log of 6 I divide by. I'm going to get x is equal to, I have log of 21 divided by 2 log of 6. I'm going to do this in my calculator. And when I do that, I'm going to get x is equal to 0.850. And that's my answer. For the third problem, I'm going to do log of both sides. First step is taking the log of both sides. So I take the log of both sides. I'll have the log of 3 to the x plus 4. Wait, sorry. Not the log. Log of 3 to the x plus 4 is equal to log of 101. I'm going to take this exponent, so the exponent is x plus 4. I'm going to move it to the front. I need to be careful with this because this is an expression, so I need to put this in parentheses. I'm going to put it in parentheses. I know I'm multiplying both x and 4 by the logarithm, not just 4. So I need to make sure I put that in parentheses. So I'll have x plus 4 in parentheses times log of 3 is equal to log of 101. From here, I'm going to get rid of everything I can to eventually get back to that x by itself. I can only, for starters, get rid of the log of 3 first. So I'm going to divide by log of 3 on both sides first. I'm going to end up with x plus 4. Now I've gotten into the parentheses. I have x plus 4 is equal to log of 101 divided by log of 3. And if I do this in my calculator, I'm going to get, I'm going to get 4.201. So I'll have x plus 4 is equal to 4.201. I'm going to subtract 4 on both sides. And when I do that, I'll find that x is equal to 0.201. And that's my answer. Oops. All right, so that's exponentials with an exponential on just one side. For exponential equations with exponentials on both sides, that means I have a base raised to some exponent on both sides, a base raised to an exponent. Here are the steps for solving that. The first thing you're going to do, you're going to rewrite. So you're going to rewrite both sides in terms of the same base. So rewrite both sides in terms of the same base. And for this example, that would mean 5 and 25. I need to find what base do they share in common. Well, that's 5. So I'm going to rewrite the left-hand side. I'm not going to rewrite the left-hand side. It's just 5 raised to the x power. It's already written base 5. The right-hand side, I have 25 as 5 to the second power, and that's being raised to the x minus 1 power. So what I actually have here is 5 to the x power is equal to 5 to the, if I have a power to a power, I multiply. So I make sure I distribute that 2 to both the x and to the negative 1. I'll have 2x minus 2. That's the power for 5 on the right-hand side. And then what I'm going to do is I'm going to, just like we did in the last unit, I'm going to set the exponents equal to each other. Because for these two sides to be equal, the exponents need to be equal to each other. I need to be raising 5 to the same power on both sides. So I'm going to set the equations equal to each other. I'm sorry, set the exponents equal to each other. I have then x is equal to 2x minus 2 is what I have. X is equal to 2x minus 2. And then I'm just going to solve for x. I'm going to solve for x. So I have x is equal to 2x minus 2. I'm going to subtract 2x on both sides. I'm going to get negative x is equal to negative 2. And that leads me to x is equal to 2 is my answer. So x is 2. All right, for the problems I have here, they have exponentials on both sides. A base raised to an exponent, base raised to an exponent, base raised to an exponent, base raised to an exponent. And this one's the same. So for the first one, I'm going to rewrite both sides in terms of the same base. I'm going to start with, oopsies. I want to tell what base do 3 and 9 share in common, and that base is 3. So I'm going to leave the left-hand side alone, 3 to the x power, and on the right-hand side, I'm going to rewrite that as 3 to the second power is 9, raised to the 3x power. That's being raised to the 3x power. I know if I have a power to a power, I multiply the two powers together to simplify. So I'll have 3 to the x power is equal to 3 to the 6x power. And then I set the exponents equal to each other. For these two sides to be equal, the exponents need to be equal. So x needs to be equal to 6x. And you should be able to tell right off the bat what that means. X has to be, but if you can't, you'll subtract x on both sides. You'll get 5x is equal to 0. Divide both sides by 5, and you can see that x is equal to 0. So x is equal to 0 for this problem. For number 2, I have 4 to the 2x power is equal to 16 to the 2x plus 2 power. I want to know what base do 4 and 16 have in common, and that base is 4. I leave the left-hand side alone, 4 to the 2x power, and on the right-hand side, I have 4 to the second power raised to the 2x plus 2 power. So I rewrote 16 in terms of 4 to some power. And then I know if I have a power to a power, I multiply the powers together to simplify. So I have 4 to the, I need to distribute that 2 to the 2x and to the 2. So I have 4 to the 4x plus 4 power is equal to 4 to the 2x power. The next thing I do, I set these exponents equal to each other because they have to be equal to each other for the sides to be equal. I have 2x is equal to 4x plus 4. From there, I'm going to solve for x. I'm going to subtract 4x on both sides. And I'll get a negative 2x is equal to 4. I'm dividing both sides by negative 2. I get x is equal to negative 2 is my answer. For the third example, I have these two sides share a base of 2 in common. The left-hand side I don't need to change, 2 to the x plus 4 power. The right-hand side I'm going to change to 2 to the 5th power. That 32 is 2 to the 5th power, raised to the 2x plus 1 power. I have a power to a power, so I multiply the powers together to simplify. I have 2 to the, make sure you distribute that 5 to the 2x and to the 1. You'll have 10x plus 5 power. 2 to the x plus 4 power is equal to 2 to the 10x plus 5 power. You're going to set these exponents equal to each other. They need to be equal for the sides to be equal. I need to be raising 2 to the same thing on the left and the right. I have x plus 4 is equal to 10x plus 15. From here, I'm going to solve for x. I'm going to subtract 10x on both sides. I'm going to subtract 10x. I'll get negative 9x plus 4 is equal to 15. I'm going to, did I do that wrong? Is equal to 5. Why did I write 15? Whoops. Is equal to 5. And I have negative 9x plus 4 is equal to 5. I'm going to subtract 4 on both sides. I'm going to get negative 9x is equal to 1. I'm going to divide both sides by 9, and I get x is equal to, negative 9, sorry. And I'm going to get x is equal to negative 1/9 is my answer. Next, we're going to talk about logarithmic equations with logarithms on just one side, not both sides, just one side. So I only see logarithms on the left-hand side here. The first thing that I'm going to do, the first step, is to rewrite. I'm going to rewrite the equation so there's only a single logarithm by itself on one side. So I'm going to rewrite, and we know how to do that. We did that last unit. Rewrite the equation. So there is a single logarithm on one side by itself. So I have, first thing I'm going to do in order to condense this side, I need to get rid of the coefficient that I see. So I need to make that coefficient an exponent instead. That's the first step. So I'm going to make it log of x to the third power minus log of 2 is equal to 5 is what I have. And then I can consolidate these two logarithms with the same base. So I'm going to have log of, I'm going to multiply, I'm going to divide. If I see subtraction in between two logarithms, to combine them, I'm going to divide. I have x cubed divided by 2 inside is equal to 5. The next thing I'm going to do is I'm going to rewrite the equation in exponential form. So when I have a missing variable in logarithm form and I can't solve it, I change it to exponential form. So I'm going to rewrite the equation in exponential form. And what I need for that is I need to know what the base is here. I know if I don't see a base, the base is 10. This base is 10 here. I'm taking 10, I'm raising it to the 5th power, and that's going to give me what's inside of the logarithm. So I have 10 to the 5th power is equal to x cubed divided by 2. And then I'm going to just solve for x. I'm going to solve for x is the last step. So what I have here, I'm going to do 2 times 10 to the 5th power is equal to x cubed. I'm going to multiply both sides by 2. And that's going to cancel out the 2's here. I'm going to end up with, on the left-hand side, I'll have 200,000. So 200,000. And on the right-hand side, I'll have still x cubed. To get back to x by itself, I'm going to take the cubed root of x cubed. And when I do this in my calculator, I'm going to end up with oops. Don't know how to use a calculator. I get 58, so x is equal to 58.480 if I round to the nearest thousandth place. And that's how you do it. These equations all have logarithm, just one logarithm, only logarithms on one side. So for number 1, the first thing I'm going to do is I'm going to rewrite this so it's a single logarithm. Oh, never mind, that's already done. I don't have to do anything. The first thing I'm going to actually do, I'm going to skip step 1. I'm going to go to step 2. I'm going to rewrite the equation in exponential form. So I'm going to have this base is 10. I'm raising 10 to the 4th power, and that's going to give me what's inside. So 10 to the 4th power gives me 2x minus 2. And then I'm going to solve for x. So on the left-hand side, that is 10 to the 4th power is 10,000. That's equal to 2x minus 2. I'm going to add 2 on both sides. I'm going to get 10,002 is equal to 2x. I'm going to divide both sides by 2, and I'm going to find that x is equal to 5,001. And that's my answer. For number 2, I have 2 logarithms on the left-hand side. I need to consolidate that to 1 logarithm. So I'm going to use step 1, rewrite the equation. So there's a single logarithm on one side by itself. I have to get rid of this coefficient. I need to make it a exponent instead. So I'm going to have log of x to the second power raised to the second power minus log of 2x to the second power is equal to 3. I need to make sure I'm distributing, for this, I'm going to rewrite it as log of x to the fourth power. Power to a power, I multiply the powers together to simplify. So this is what I'm going to end up with. Log of x to the fourth power minus log of 2x squared is equal to 3. I'm going to combine these two. There's subtraction in between. I'm going to combine them with division. So I'll have log of x to the fourth power divided by 2x squared is equal to 3. I can simplify this to be log of, I have x to the second power in the top. I have 4 x's in the top and 2 x's being multiplied in the bottom. That's an extra 2 in the top. So I have x to the second power in the top over 2 is equal to 3. And now I'm going to rewrite this in exponential form. So I have log base 10. I know it's base 10. If I don't see a base, I'm going to write 10 to the third power gives me this thing inside. So 10 to the third power gives me x squared divided by 2. I'm going to solve for x now. I'm going to multiply by 2 on both sides. I'm going to get 2,000. That's 2 times 1,000 is equal to x squared. I'm going to take the square root of both sides, and I'm going to find that x is equal to, when I do that, it's plus or minus, since it's the square root, and I'm taking it, 44.721. That's what x is equal to. For number 3, I need to get this single logarithm by itself on one side. One way I can do that easy, instead of making this an exponent, I can divide both sides by -6. So I'm going to divide both sides by -6. And I'm going to get log base 3 of x minus 3 is equal to 4. This is one single logarithm on one side. And now it's consolidated on one side. Now I can rewrite this in exponential form. So I have base 3 to the fourth power gives me this answer. So 3 to the fourth power gives me x minus 3. I'm going to now solve for x. 3 to the fourth power is 81. I have 81 is equal to x minus 3. I'm going to add 3 on both sides. I'm going to get x is equal to 84 is my answer. Then the last thing we're going to talk about, so that's logarithmic equations with logarithms on one side. And the last thing we're going to talk about is logarithmic equations with logarithms on both sides. The steps to solving those problems, the first thing we're going to do is we're going to rewrite. So we're going to rewrite the equation. So there's a single logarithm on both sides. Rewrite the equation. So there is a single logarithm on both sides. So just one single log on the left and one single log on the right. For this, the left-hand side, there's multiple logarithms. I need to bring those together. There's no coefficients, so I can immediately bring them together. I'll have log of 2x squared times 2x is 2x cubed is equal to log of 16. From here, the next step, I'm going to set the insides equal to each other. I'm going to set the insides equal to each other. Okay, what's inside of this logarithm has to be equal to this logarithm if they're the same base, for these sides to be equal, just like when exponents need to be the same. What's inside of the logarithm needs to be the same. So 2x cubed needs to be equal to 16. Then I'm just going to solve for x. The last step is to solve for x. So I have 2x cubed is equal to 16. I'm going to divide 2 on both sides. I'm going to get x cubed is equal to 8. I'm going to take the cubed root of both sides. And that's going to give me x is equal to 2. So for this first problem, the first thing I'm going to do, I'm going to write both sides just to have one logarithm. This has 2 logarithms, so I need to consolidate. There's no coefficients, so I can just consolidate as is. I have log base 9 of this. I'm subtracting. I am subtracting in between the two logarithms, so to collect them, I'm going to divide. I have x plus 6 divided by x inside of the logarithm, and that's equal to log base 9 of 2. These two logarithms have the same base, which means their insides need to be equal to each other. X plus 6 over x needs to be equal to 2 for these two sides to be equal. So I'm going to write that. X plus 6 divided by x is equal to 2. That's the second step, set the insides equal to each other. And then I'm going to solve for x. That's my last step. So I'm going to multiply it by multiply by x on both sides. I'm going to have x plus 6 is equal to 2x. I'm going to subtract x on both sides. I'm going to get x is equal to 6, and that's my answer. X is equal to 6. For number 2, I want to consolidate these logarithms on the left-hand side. I don't have any coefficients, so I can immediately do that. I'm going to have, there's addition in between, so I'm going to consolidate with multiplication. I have log base 5 of 6 times 2x squared is 12x squared is equal to log base 5 of 48. From here, I'm going to set the insides equal to each other. I know this needs to be equal to this for the sides to be equal, since they have a logarithm of the same base on both sides. So I have 12x squared is equal to 48. I'm going to solve for x now. My third step is to solve for x. I'm going to divide both sides by 12. I get x squared is equal to 4. And then I'm going to take the square root of both sides. I get x is equal to both positive and negative 2. Or one or the other. Not both. Plus or minus 2.